Welcome back. In this lecture, we're going to go over the solutions for the Level 2 problems in the Function Practice Problems notebook. Let's get started. Alright, so here we are at Level 2 problems. The first problem we had was find 33, which was given a list of integers, return true if this list or array contains a 3 next to a 3 somewhere. So here we can see 3 and 3 are together, so we say true. Here the 3's aren't connected anyway, so we say false, and again here 3's aren't connected together, so we say false. So if we basically get two 3's in a row, we know to return true. So to do this, we'll do the following logic. We'll say for I in range from 0, and we actually don't want to go all the way to the end of nums. We want to go to the length of nums minus 1, because we want to go up to the second to last digit so we can check the very next digit. If we went up to the last digit, there would be no next digit to check, which is why we're going to say for I in range from 0 to length of nums minus 1. So this is part of the trick already. And we can say if nums of I is equal to 3 and nums of I plus 1 is equal to 3, then return true. Otherwise, what we're going to do is return false. So notice what I'm doing here. I'm going to run through a for loop that goes through every single index position in this list up to the second to last one. And then what we're going to do, here is check that number and the number right next to it. So nums of I, and the number right next to it is nums of I plus 1. And if they're both 3, then we're going to return true. If we go through this entire for loop and we never execute this return statement, then we know there are no 3's together and we'll return false. So let's run this and check it out. We're going to copy this, paste it here, run that, and we get back true. Let's check one of the false ones, see if it also works. Put that in, run it, and we get back false. Perfect. Now, the other alternative we could do that it doesn't look as nice as this if statement is to say if nums of I sliced to I plus 2 is equal to the list 3, 3. This is actually the exact same thing as before. It just is, in my opinion, a little less readable, but it is technically a little sleeker because you're just doing one slice and one comparison instead of two comparisons. So all this is doing is grabbing slices at a time and comparing them to this sublist 3, 3. All right, let's move on to this problem called paper doll. So for this paper doll problem, we wanted to say, given a string, return a string where for every character in the original, there are now 3 characters. So essentially go along and create 3 of these characters. So 3 H's, 3 E's, 3 L's, another set of 3 L's, and then 3 O's. And this problem is actually not so bad once you figure out the trick is to start with an empty string and then to keep concatenating to that string. So I'm going to say result starts off as an empty string. And then for every character in that text that I pass in, I'm going to grab my current result, so that current string, and I'm going to add on that character times 3. The other thing I could do is say character plus character plus character. So times 3, or 3 characters concatenated together, that's the same thing. And then at the end of this for loop, outside of it, I'll just say return result. And that's actually all you had to do. So the main trick here is realizing that you can continually concatenate to that string. The next question was called Blackjack, which is basically using the Blackjack card game as a base for the given problem statement. We were given 3 integers between 1 and 11, and if their sum is less than or equal to 21, we just return their sum. However, if their sum exceeds 21 and there's an 11, we get a chance to reduce the total sum by 10. And then finally, if that sum, even after adjustment, exceeds 21, we return bust. So let's check this out. The first thing we'll do is just actually check if their sum is less than or equal to 21. And we can do this by saying if sum of A, B, C is less than or equal to 21, return back that sum. We'll say sum of A, B, C. So sum is a nice built-in function you can use. Alternatively, you could have just said A plus B plus C. So that's the same thing as passing in this list here of A, B, and C. So we'll be using the sum keyword because it's a little more readable. All right, the next thing we're going to check is the second case, which is where we actually have an 11 there. So remember, when there's an 11, we get to reduce the total sum by 10. And then we actually check if it exceeds or not. So something we can do is say the following. Elif there's an 11 in the list A, B, C. So if there's an 11 in there, and the sum of these three put together is less than or equal to 31, because remember, we get to reduce the total sum by 10 when there's an 11 there. So basically, we get to check it against 31 this time. Then we get to return the sum. So then we can return the sum of this, ABC, except we're going to subtract now 10 from this. So this less than or equal to 31, basically what we're doing is now, instead of checking less than 21, because beforehand we're able to reduce the sum by 10, that means we get to check against 31. So the other way of doing this is saying sum of ABC minus 10 is less than or equal to 21. So those are the same things. And it's up to you which logic you prefer, whether you prefer to take the sum, then subtract 10, and then check if it's less than or 21, or if you just like to do the check against 31. So that's technically the same thing there. Finally, if that doesn't happen to be the case, then this person has busted, so we return bust. So now when we run this, we get back 18, bust, and then we run that one more time, we get back 19. Okay, let's go to the next problem, which is summer of 69. We wanted you to return the sum of the numbers in the array, except ignore sections of numbers starting with a 6 and extending to the next 9. So every 6 will be followed by at least one 9, and we return 0 for no numbers. So what does that actually mean? Well, we can see here 3 different examples. Here we have 1, 3, 5, so there's no 6s or 9s there, so we return back the sum of all of them, which is 1 plus 3 plus 5, which is 9. Here we get back 4, 5, and then we have a 6, 7, 8, 9. So 6 through 9 here are going to be ignored. So that's the summer of 69. We're ignoring it because, let's say, nothing got done there. So then we just add 4 plus 5, and we get back 9. Here we get 2, 1, and then we have a 6 and a 9. So these two numbers plus anything in between gets ignored. And then we see 11 there, and then we get back 14. And we also noted that every 6 will be followed by at least one 9 when you're given in this list. So you don't need to worry about some sort of weird edge case where you just have a 6 and then you're waiting for a 9 that never comes. Okay, so let's get started on this. The way we're going to do this is start with a running total. We'll say total is equal to 0. And I'm also going to create a Boolean value called add. And I'm going to set it to true first. And I will say for num in my array or in my list, while add is on, so while I'm still adding, while that's true, and we start off with true, if the current number is not equal to 6, then I'm going to take my total and I will add num to it. And then I will break out of here. Else, what I'm going to do is set add equal to false. And then lined up with this while loop, what I'll do is set up while not add. The other way to say that is while add is not equal to true. If num is not equal to 9, then I'm going to break. Else, I'm going to add, set that back equal to true, and then break here. And then finally, after all of this, outside of this for loop, I'll return the total. So let's run this, and then we'll break down the explanation. Okay, so it looks like we got 9 here, that looks good. We got 9 here, that looks good, 4 and 5 together, ignoring all this. And then summer 69 here, we just get 2 plus 1 plus 11, which is 14. So what's actually happening here in our logic? Well, we have our total, which is 0, that makes sense. And we have this Boolean condition called add, which is equal to true. And basically, by default, I'm going to assume that I'm going to keep adding all the numbers in this list or in this array. So then I'm going through the array, and I'm saying, okay, for every number in the array, if my add statement is true, then I'll do the following check. If the number doesn't happen to be 6, I will say, take the total, add the number in there, and then I'm going to break out of that loop. So I'm going to break out of this enclosing loop, which is the while loop, which brings me back then to the for loop, and I continue along. Then I'm going to say else. So let's say the number was 6, so this doesn't happen to be true. Then I set add equal to false. So in that case, now I'm just waiting for the 9. So I'm right now in the summer of 69, and I have to keep going waiting for the 9. So I'll say while not add. If num is not equal to 9, then I will break out of this while not add. Else, I will say add is equal to true, and then I will break. Okay, so this one's definitely a little tricky because we're using breaks here, and we have a nested loop situation. We have a for loop with 2 while loops nested in there. So the key thing to notice here is that this break is only connected to the while loop it's in. And these breaks are only connected to the while loops they're in, which will bring you back to this for loop so you can continue on with the numbers. I would say this is definitely probably the hardest problem, I would say, in this entire challenge, as far as the ones that aren't specifically challenging problems. But even I think that this summer of 69 is probably even harder than this first challenging problem. Okay, in the very next lecture, we'll finish off our discussion by going through these challenging problems and their solutions. We'll see you there.